cannot provide information about stapling in relation to British standards because the information provided does not include details on the subject. Without specific details on stapling methods and their relation to British standards for cable management, I am unable to offer a comprehensive answer. Generally, cable management techniques adhering to standards prioritize safety and secure installation. Clamps typically offer adjustable pressure via tightening mechanism, while clips use spring tension for support. However, I lack information on whether stapling is a recognized or equivalent method within British standards. Providing context and further details will enable me to furnish a helpful and relevant response. British standards are a set of guidelines and specifications developed by the British Standards Institution, often abbreviated as BSI. These standards cover a wide range of products, services, and processes, and they are designed to ensure quality, safety, and reliability. In the context of electrical installations and cable management, British standards would specify requirements for materials, installation methods, and performance criteria. These standards aim to prevent electrical hazards, ensure proper functioning of electrical systems, and promote consistent practices across the industry. They address issues such as cable sizing, protection against overcurrents, grounding, bonding, and insulation. Cable management is a crucial aspect of electrical installations, involving the organization, support, and protection of electrical cables. Proper cable management practices are essential for several reasons. Firstly, safety. Secondly, preventing electrical hazards such as short circuits and fires. Thirdly, ensuring the reliable operation of electrical systems. Fourthly, facilitating maintenance and repairs. Fifthly, complying with regulatory requirements. Cable clamps and clips are two common types of cable management devices. Cable clamps are designed to secure cables in place and provide adjustable pressure through a tightening mechanism. This allows for a firm grip on the cable, preventing it from moving or becoming damaged. Clamps are often used in situations where cables need to be securely fastened to a surface or structure. Cable clips, on the other hand, rely on spring tension to support cables. They are typically used for lighted-duty applications where cables need to be held in place but do not require the same level of security as clamps. Clips are often used to route cables along walls or ceilings. Stapling, as a method of cable management, involves using staples to fasten cables to a surface. While stapling can be a quick and easy way to secure cables, it is important to consider the potential risks associated with this method. One major concern is the possibility of damaging the cable insulation if the staples are driven in too tightly. Damaged insulation can lead to short circuits, electrical shocks, and fires. Additionally, staples may not provide the same level of support and security as clamps or clips, especially in situations where cables are subject to vibration or movement. If stapling is permitted under British standards, there would likely be specific requirements for the type of staples to use, the spacing between staples, and the method of installation. These requirements will aim to minimize the risk of cable damage and ensure that the cables are securely supported. It is essential to consult the relevant British standards documents to determine whether stapling is an acceptable practice and, if so, what the specific requirements are. The NEC, or National Electrical Code, is a widely adopted standard for electrical installations in the United States. While British standards and the NEC differ in their specific requirements, they share the common goal of ensuring safe and reliable electrical systems. The NEC provides detailed guidelines for cable management, including requirements for cable supports, securing methods, and protection against physical damage. Article 300 of the NEC covers general requirements for wiring methods and materials. This article addresses issues such as the proper use of raceways, cables, and conductors, as well as the requirements for supporting and securing wiring. Article 310 of the NEC covers conductors for general wiring. This article specifies the allowable ampacities of conductors based on their size, insulation type, and operating temperature. It also includes requirements for Dayton conductors when multiple conductors are installed in the same raceway or cable. Article 334 of the NEC covers non-metallic sheathed cable, often referred to as Romex. This type of cable is commonly used in residential wiring. The NEC specifies the requirements for installing and supporting non-metallic sheath cable, including the maximum spacing between supports and the methods for securing the cable to walls and ceilings. When installing electrical wiring, it is important to follow the applicable codes and standards to ensure safety and compliance. This includes using the proper wiring methods, selecting the appropriate conductors and cables, and providing adequate support and protection for the wiring. Failure to comply with these requirements can result in electrical hazards, equipment damage, and legal liabilities. Electrical systems operate on various voltages such as 120 volts, 208 volts, 240 volts, 277 volts, and 480 volts. The choice of voltage depends on the application and the power requirements of the equipment being served. In residential settings, 120 volts is commonly used for lighting and small appliances, while 240 volts is used for larger appliances such as electric stoves and dryers. In commercial and industrial settings, higher voltages such as 208 volts, 277 volts, and 480 volts are often used to power machinery and equipment. The electrical current is measured in amps. The amount of current flowing through a conductor depends on the voltage and the resistance of the circuit. Higher voltages typically result in lower current flow for the same amount of power. Electrical resistance is measured in ohms. Resistance opposes the flow of current in a circuit. Conductors with lower resistance allow more current to flow, while conductors with higher resistance restrict current flow. Ohm's law states the relationship between voltage, current, and resistance. It states that voltage equals current multiplied by resistance, or volts equals amps x ohms. This law is fundamental to understanding how electrical circuits work. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of electrical fires. Circuit breakers are reusable devices that can be reset after tripping, while fuses are one-time devices that must be replaced after they blow. Branding is an important safety measure in electrical systems. It provides a low-resistance path for fault current to flow back to the source, allowing overcurrent protection devices to trip and to energize the circuit. Grounding also helps to prevent voltage buildup on metal surfaces, reducing the risk of electrical shock. Bonding is the process of connecting metal parts of an electrical system together to create a continuous electrical path. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. Bonding is typically accomplished by using bonding jumpers or other approved bonding methods. Insulation is used to prevent electrical current from flowing through unintended paths. It is applied to conductors and other electrical components to isolate them from each other and from ground. Insulation materials are typically made of non-conductive materials such as plastic, rubber, or ceramic. Electrical enclosures are used to protect electrical equipment from the environment and to prevent accidental contact with energized parts. Enclosures are typically made of metal or plastic and are designed to provide a barrier against moisture, dust, and other contaminants. Electrical codes and standards, such as British standards and the NEC, provide detailed requirements for electrical enclosures, including their construction, installation, and use. In summary, electrical installations involve a wide range of considerations, including cable management, voltage levels, current flow, resistance, overcurrent protection, grounding, bonding, and insulation. Compliance with applicable codes and standards is essential to ensure the safety and reliability of electrical systems. If you have any further questions about electrical installations or cable management, please provide more details so that I can give you a relevant answer.